I want to go over graphing messy trig, but I have a video up on how to do it on the TI. I want to do the same thing now, but using Desmos for those of you who either don't have a TI or the TI is giving you the heebie-jeebies. So this is the same equation I used on the other one, just so that kind of see they work the same way. And I'm going to go over all the things you need for the trig assignment problems. So first thing I'm going to do is I'm going to do it. Now you'll notice that if you looked at the trig assignment, it is in g and theta. It doesn't matter what these two variables are, x and y, g and theta. I would probably, for graphing in Desmos, or graphing on the TI for that matter, it's easier to use y and x. So that's what I'm going to use here. I don't want this one here. Okay, right here. So y equals 10.44. Doesn't really matter what I do here, but let's be consistent. 0.005 sine squared x minus 0.028. Okay, sine squared 2x. Make sure to use parentheses. Parentheses are your friend, just like on the TI. Okay, now you'll notice this isn't showing. So I'm going to, and I'm just using my mouse, but if your mouse doesn't work or whatever, you can go over here and you want to use this graph setting, so the wrench, and you can change these. So for instance here, this x-axis, I'm going to go, so I know that, and so here I'm going to do, so that is in theta, right? And so what does the globe go for? It goes from negative 90 to positive 90, right? But we're in radians. So 90 is pi over 2, which is about 1.57. So I'm going to go from negative 2 to 2. And my step is going to be pi over 24. I just want a small step. Now, the y-axis, I know that this is the constant 10. I know it's going to be around there. I can also see that. So I'm going to go from, say, 9 to 11. And I'm going to count by 0.1s. And again, doesn't matter. And you can do something like, oh, you know, maybe I want that to go out a little bit farther. So I can see right here I'm going from this. So I'm going to go now from, say, 10.1 to 10.8. You know, and again, I'm just playing with it until it looks right. And that's the same thing I was doing on the TI. Now, I do want to make sure, again, with whatever I'm doing, that I can see, when I come down here to the x, I want to make sure the x is also, it's easier to lose this way. I'm going to come back here. So I'm going to get this. So I decided that, say, hey, I wanted to go to 10.1 to 10.8. Now, I'm going to come back. You'll notice this automatically adjusted. I'm going to come back up here and do that again, because again, I'm trying to get just the area. So now what I'm looking at is I can see the wave, and I'm in that general vicinity that is the globe, because I know that when I'm looking at that, I'm going from negative pi over 2 or negative 90 to positive 90 or positive pi over 2, because that's the way latitude works. So I've got this. So this is the part, if when you look at the trig assignment, the first question was just, what's the graph? What is my thing? So pick a graph, then you want to show me your wrench here, whether you write it down or you take a screenshot of this. And screenshots usually are the print screen key on your keyboard. It says print screen. It's up near backspace and insert, at least on my keyboard. So that's the first step, get it graphed. Now this says you want to find 34 degrees. So I'm just going to pick a, right 9 number. So 30 degrees. So actually, let's be weird. Let's do like 28. So I need to first convert this to radians. So 28 times pi divided by 180. Okay, this is just the typical conversion. I want the decimal. So this tells me it's about 0.49. The reason I need to know that is that I'm looking here on my graph, and I need to come out here, and so I'm looking, just click it here, I'm looking for 0.49, so like right there. So I can see that then this point at 0.49, the answer would be 10.42. So when this asks you this, find wherever 34, whatever the decimal is, and see what the y value is, because you want, they're giving you theta, they're giving you the degrees, in this case x theta is the same thing, we're just using them interchangeably here. They're giving you that, they want you to give you g or y. So in this case, I would look that up. I found it, okay. Yeah. And you just kind of have to play around until you find it. Okay, now that I found it though, then I click there's my answer. And again, you can just take a picture of this or you can write it down. Okay, so that's the same thing. This, you're going to Google where your hometown is. So Google, so it doesn't matter what it is here. Hold on a second. So, latitude for Grand Forks, North Dakota. That's not my hometown, but I lived there at one point. And it's going to tell you what it is, and you want the north-south. So you just Google it, whatever it is, and look, and then you're going to do the same thing. Convert it to radians, get the decimal so you can look on the graph. Okay, so A, B, C. And again, with the work or calculator screen, I'm meaning just, again, showing you this, something like this, okay? You can crunch it. You can put in this equation and crunch it through, but it is a pain in the butt. It takes me 3 attempts usually to get the right answer because it's really easy to screw stuff up. I would use your graph. That's what it's there for. Okay, where's the greatest G and the least? Okay, so the greatest is going to be where the min is, right? So you're looking for the highest point. So when I look at this, I can see that the mins here are right there, and here are the leasts. Now I change this around so it's different, but that's what you're looking at. You're looking at, and the nice thing about Desmos is it will always have the buttons where the top and the bottom are. And you're looking it up, and then just think about what it means for the graph. The points are going to be really obvious, guys, if you think about it. Just remember that they're going to give it to you, and so like this here, this is negative pi over 2. That's negative 90. What is that? That's the South Pole, guys. This over here, that's the North Pole. This would be the equator. This would be somewhere in between them. So again, you're just going to look at it and you're going to see what those graphs mean for you. Okay? And you're just, again, you're looking for the peaks and the valleys. And remember, you're only going from here. These are your endpoints because the globe doesn't go, you shouldn't tell me it's, negative 145 degrees. There is no latitude like that in the globe. So these are your kind of absolutes. You're looking between here. Now I change this isn't your graph, so you're going to look and you're going to see what makes sense. You should have 1 min and 2 maxes. Okay, that's my hint there. Okay, and then the greatest in the US. So what you're going to do is you're going to think about D, and you're going to go, well, what's the closest to whatever you found as the greatest? What is the closest to whatever you found as the least? And again, you can just Google it. Once you know, like, okay, I need closest to point X, Google will tell you what that thing is, and then just give me the latitude and the gravity. And that's all there is to it. So once you get the graph, you're just going to use that, whether you're finding along to find the point you want. So, for instance, we made this up, say, Grand Forks was, I already forgot what Grand Forks was. North Dakota latitude. Hold on a second. Okay, so 48. So I would go 48 pi divided by 180. So I would look up 0.84 on here. I have too many screens. 0.84. And I'm just looking for it. Because it's north, so it's up here. So all the souths are the negatives, the norths are the positives, in case you were wondering. And I'm just going to look for right there. So there, 10.415 would be the answer if this was the right equation. And it's not, but give you the idea. That's all you're doing. You're finding it on there. This is the same as really using the table function or using the trace function. I don't know if there's a way to get to the table on here. This, though, is a lot easier to trace, unlike the TI, so it's not as important to use like a table function as is on the TI. It's also bigger, and my old lady eyes do like bigger. Remember also this is an app on your phone, and you can do the same thing on your phone if that's easier or better for you for any reason. But I do like, again, old lady eyes, I like the largeness of my computer screen. So hopefully this helps you.